Hi, my name is James Hill, and I'm the Research Director at NanoAffix Science in Milwaukee, Wisconsin. I'm excited to have the opportunity to share with you today some of the technology that we've been developing to provide testing for lead in drinking water. This is a graphene-based sensor, and it's a patented technology that can be used as a platform to detect many different toxic contaminants in drinking water or in air. We're excited to have a beta testing program that's ongoing and soliciting feedback from potential future customers. And our goal is to launch our initial product at the beginning of next year. Lead itself is a very serious problem in drinking water. Exposure to even small amounts, especially in childhood, can cause long-term neurological issues, long-term disabilities. And just to give you an idea of how widespread it is, our word for plumbing is derived from the same Latin word that lead is represented by on the periodic table, the Pb or plumbum, just to give you an idea for how ubiquitous it is. The current testing methods are relatively slow and expensive, which causes them to be formed too infrequently. Lead levels in water can change from day to day, week to week, and even places that test rarely test more than once a year. So at NanoAffix, we think we've developed a solution to address this that will help people test for toxic contaminants such as lead in drinking water more frequently. Our goal is to strive to provide accurate, affordable analysis. It's rapid, where results can be obtained in minutes. We don't have to wait several days to ship a sample off to a contract lab and wait for results. It's accurate. We can get down below the EPA MCL of 15 ppb, and we can get down to single-digit part per billion, provide quantitative results. And it's affordable. Each test itself will be less than $20. It makes it less expensive than other portable units and contract labs. And it's designed to be portable, so it can easily be carried around to various point sources to collect samples and perform the measurements on site in real time. And as I mentioned before, we're working on developing tests for other contaminants that can be found in drinking water as well, such as E. coli and other bacteria, other heavy metals such as arsenic, cadmium, etc. But our long-term goal is to eventually modify this to be used for inline or continuous monitoring. This patented technology is predicated on using graphene to bridge gold interdigitated electrodes, and the specificity is controlled by the probe that is attached to the surface. So after we functionalize the surface with the necessary probe, that makes it selective towards our particular target, in this case lead. Graphene has some unique properties that make it perfect for this particular application. It's very sensitive to small changes in the surface, and these surface modifications can cause a change in conductivity or resistivity, which is measured and can be correlated back to lead concentration. Here's some example data from our product. You can see we have the sensitivity down to 1 ppb. Response time is quick, less than 5 minutes for soluble lead. Dimensions, these are very small, portable, easy to carry around, about the same size and weight as a smartphone. And they also use lithium-ion batteries that can be recharged. Next, I'd like to show a brief how-to video of our device. It comes in a rugged carrying case to easily take it out into the field and collect measurements on site. The first step is collect a water sample from some source, such as your kitchen sink. Next, add that to the test tube. If you'd just like to test for soluble lead, the sample could be immediately added to the sensor. Or if you'd like to get a total lead reading, a combination of soluble and insoluble lead, we'll need to add our lead digestion solution to the mix and let that react for about 10 minutes. After mixing thoroughly and waiting the appropriate amount of time, you can begin your analysis. Remove the cap, which is held in place by a magnet. Grab one of the sensors, careful to grab only by the blue silicon substrate. And avoid handling the gold sections as much as possible. Insert them into the sensor. Make sure that you have a good connection. return the cap, which ensures it has a watertight seal and that your water sample is only exposed to the active area of the sensors. After the device is turned on, pull up the app on your smartphone and begin by creating a file that you can use to save the data to. Then ensure that you're connected to the device via Bluetooth by scanning for all Bluetooth devices in the area and selecting the appropriate device, which will begin with PS, and it should match the MAC code on the back of the device. Hit Next after confirming that you've loaded the sensors into the device. Hit Start and it'll run a background scan on the dry sensors. Once this test is completed, add your water sample to each of the two devices, 200 microliters to each sensor. Confirm and hit Start. The entire test takes about 30 seconds. And in the end, you'll get a reading of your lead in parts per billion. So thanks again for the chance to present this technology to you. And we're excited at NanoAffix to be inventing the future of sensing and providing accurate, affordable analysis of toxic contaminants in drinking water.